Hey everyone, welcome back. Before we dive deep into today's truly explosive topic, I'm sending out a massive wave of good vibes and the very best wishes to all of you watching. Wherever you are in the world, I genuinely hope you're feeling fantastic, taking excellent care of yourselves, and staying healthy. That's the absolute foundation for everything good. Now, grab your virtual snorkels, because we're about to plunge beneath the waves to explore one of Earth's most powerful and surprisingly common secrets. There are way more volcanoes under the ocean than there are on land. Yeah, you heard that right. While we might picture dramatic, cone-shaped mountains spewing lava on continents, the real hotspot for volcanic action is hidden far below the ocean's surface, in a world of darkness and crushing pressure. We're talking about thousands upon thousands of fiery mountains down there, silently shaping our planet in ways we're only just beginning to understand. It's a hidden landscape that makes the volcanic activity we see above water look like just the tip of the iceberg, or maybe, just the tip of the volcano. So, just how many are we talking about? Picture every volcano you've ever heard of: Mount Fuji, Mount Vesuvius, Mount St. Helens, Kilauea, all of them. Now, imagine that number. Got it? Well, scientists estimate that there are potentially over 1 million underwater volcanoes, or seamounts, scattered across the ocean floor. Even more mind-blowing? Roughly 80% of all volcanic activity on Earth happens underwater. That means for every volcano erupting on land, there are 4 erupting unseen beneath the waves. Most of these underwater giants aren't constantly blowing their tops like some land volcanoes. Many are dormant or extinct, silent monuments to past eruptions. But thousands are active right now, constantly oozing lava, releasing heat, and adding new rock to the planet's crust. The scale is simply staggering. Imagine driving across the ocean floor. You'd encounter these massive volcanic mountains rising from the abyss every few hundred kilometers in some regions. It's a submerged mountain range network that dwarfs anything on the continents. Why are there so many down there? It all boils down to how our planet constantly renews itself, driven by the incredible engine of plate tectonics. The Earth's outer shell isn't one solid piece, it's broken into giant, slowly moving slabs called tectonic plates. The ocean floor isn't just a flat basin, it's actually the youngest part of the Earth's crust, constantly being created and destroyed. The birthplace of most underwater volcanoes is along mid-ocean ridges. Picture these as gigantic, underwater mountain ranges that snake around the entire globe like the seams on a baseball, stretching over 65,000 kilometers, 40,000 miles, making them the longest mountain chains on Earth. Right along the crest of these ridges, tectonic plates are pulling apart. As they separate, the intense heat from the Earth's mantle below melts rock, creating vast reservoirs of molten magma. This magma is less dense than the solid rock around it, so it rises upwards, filling the gap created by the separating plates. When it reaches the seafloor, it erupts, cools rapidly in the icy seawater, and solidifies into new oceanic crust. This process, happening continuously along these massive ridges, is the primary factory for underwater volcanoes. It's like a slow-motion conveyor belt of fire, constantly building new seafloor and peppering it with volcanic vents and hills. But mid-ocean ridges aren't the only hotspots, literally, for underwater fire. The other major zone is found near subduction zones. This is where the story gets a bit more destructive. Remember those tectonic plates? Sometimes, instead of pulling apart, they collide. When a dense oceanic plate smashes into a less dense continental plate or another oceanic plate, the denser one gets forced down, or subducted, deep beneath the other one, diving back into the hot mantle. As this plate sinks, it gets heated up tremendously. The intense heat and pressure cause water and other volatile elements trapped within the sinking plate to be released. These fluids rise upwards into the mantle rock of the overriding plate above it. Adding water drastically lowers the melting point of that mantle rock. Think of it like adding salt to ice, it makes it melt easier. So, this mantle rock melts, forming huge pools of magma. This magma, being buoyant, then forces its way upwards through cracks and weaknesses in the overriding plate. When it finally punches through the seafloor, it erupts, building chains of volcanoes. These often form curved lines called volcanic arcs. Some of these arcs eventually build tall enough to break the ocean surface, creating island chains like Japan, the Aleutians, or the infamous Ring of Fire around the Pacific Ocean. Many more, however, remain completely submerged, forming vast underwater volcanic ranges parallel to the trenches marking the subduction zones. So, while ridges build new crust with countless small eruptions, subduction zones create concentrated lines of often larger underwater volcanoes and island builders. What does an underwater volcanic eruption actually look like? Forget the massive, explosive pyroclastic clouds and towering ash plumes you see in disaster movies. Underwater, it's a very different, yet equally fascinating, spectacle. The key factor is the immense pressure and the cold seawater. When red-hot lava, often over 1,000 degrees Celsius or 1,800 degrees Fahrenheit, erupts onto the seafloor, it's instantly quenched by water that's often just a few degrees above freezing. This super-rapid cooling creates unique formations. The most common is pillow lava. Imagine thick, gloopy lava squeezing out of a vent like toothpaste from a tube. The outer skin of the lava blob instantly freezes solid upon contact with the water, forming a glassy crust. But the molten lava inside keeps pushing forward, bursting through the hardened skin, forming a new blob, which also freezes. This process repeats, creating piles of interconnected, bulbous lobes that genuinely look like giant stone pillows stacked on top of each other. It's slow, mesmerizing, and strangely beautiful. Sometimes, the lava erupts more rapidly, forming flat sheets or even creating jumbled piles of fragmented rock called hyaloclastite. While large, explosive eruptions can happen underwater if magma interacts violently with seawater, especially if it's gas-rich, the crushing pressure at depth usually suppresses massive explosions, making the more effusive pillow lava eruptions the signature style of the deep. The heat from these underwater volcanoes doesn't just create lava formations, it fuels some of the most bizarre and important ecosystems on the planet through hydrothermal vents. Picture this, seawater seeps deep down into cracks in the hot, newly formed oceanic crust near mid-ocean ridges or volcanic areas. As it descends, it gets superheated, sometimes to over 400 degrees Celsius, 750 degrees Fahrenheit, by the magma lurking below. This hot water becomes incredibly reactive. It dissolves minerals from the surrounding rock, becoming loaded with chemicals like sulfur, iron, copper, zinc, and hydrogen sulfide. Under immense pressure, this superheated, mineral-rich fluid can't boil. Instead, it forces its way back up through cracks and fissures, jetting back out into the icy ocean depths through chimney-like structures called black smokers or white smokers, depending on the minerals they spew. These vents look like underwater geysers, billowing dark or light clouds of mineral particles into the dark water. The water around them might be near freezing, but the fluid coming out is scalding hot, creating extreme temperature gradients. This might sound hostile, but it's the foundation for an oasis of life in the deep-sea desert. How can life thrive in such a place? Forget sunlight, the base of this food chain isn't photosynthesis, but chemosynthesis. Specialized bacteria and archaea, ancient single-celled organisms, have the incredible ability to use the chemicals spewing from the vents, particularly hydrogen sulfide, which is toxic to most life, as their energy source. They combine these chemicals with oxygen from the seawater to produce organic matter, essentially cooking their own food from the Earth's chemistry. These microbes form the foundation. They grow in thick mats on the seafloor around the vents, or they live symbiotically inside larger creatures. And what creatures? Giant, ghostly white tubeworms, several feet long, with no mouth or gut, rely entirely on bacteria living inside them to convert vent chemicals into food. Clams the size of dinner plates, covered in tough shells, burrow into the mineral deposits. Eyeless shrimp swarm around the smokers, grazing on bacterial mats or scraping microbes from surfaces. Strange, pale crabs scuttle about. Even fish specially adapted to this harsh environment can be found. These ecosystems exist in total darkness, under crushing pressure, bathed in potentially toxic chemicals, and surrounded by near-boiling water, yet they thrive with an abundance of life found nowhere else on Earth. They are independent islands fueled by the planet's internal heat and chemistry, proving life can find a way in the most extreme conditions imaginable, all thanks to underwater volcanoes. The impact of all these hidden volcanoes goes far beyond creating weird deep-sea life. They are fundamental architects of our planet. First and foremost, they are the primary builders of the oceanic crust. Every bit of the seafloor, covering about 70% of the Earth's surface, was created by volcanic activity at mid-ocean ridges. This continuous production pushes older crust away from the ridges, driving the slow but relentless movement of the tectonic plates, the very process that causes earthquakes, builds mountains, and creates the volcanic arcs we see on land. Secondly, underwater volcanoes play a crucial role in Earth's chemical cycles. The eruptions and hydrothermal vents release massive amounts of minerals and elements from the Earth's interior into the ocean. These include essential nutrients that support marine life far beyond the vent sites. They also release gases, including carbon dioxide, which eventually interacts with seawater and plays a role in regulating the planet's long-term climate. Some minerals precipitate out around the vents, forming rich deposits on the seafloor. Over millions of years, this volcanic activity has significantly influenced the composition of seawater itself and contributed essential elements to the formation of the continents. It's a slow, continuous process that has shaped the very chemistry of our world. Understanding underwater volcanoes isn't just academic, it has real-world importance. Studying them helps us better comprehend natural hazards. While most eruptions are hidden, the seismic activity associated with them, earthquakes, or the potential for underwater landslides triggered by eruptions can sometimes impact coastal areas or even generate tsunamis. Monitoring these systems contributes to early warning capabilities. Secondly, the unique ecosystems around hydrothermal vents are biological treasure troves. The extremophile microbes and the specialized enzymes they produce, extremozymes, function under conditions impossible in labs, high heat, pressure, acidity. These hold immense promise for biotechnology, medicine, think new antibiotics or cancer drugs, and industrial processes, like breaking down tough materials. Thirdly, the mineral deposits formed around vents, rich in copper, zinc, gold, silver, and rare earth elements, are potential future resources. While deep-sea mining raises significant environmental concerns, understanding how these deposits form is crucial for any future decisions. Finally, studying underwater volcanoes gives us clues about the potential for volcanic activity and hydrothermal systems on other ocean worlds in our solar system, like Jupiter's moon Europa or Saturn's moon Enceladus, expanding our search for extraterrestrial life. So, the next time you look out at the vast, seemingly calm ocean, remember the hidden fire beneath. It's not a still, silent world down there. It's a dynamic, ever-changing landscape forged by immense heat and pressure, dotted with countless volcanic mountains, crisscrossed by planet-spanning ridges, and dotted with chimneys spewing superheated, mineral-rich water that supports alien ecosystems. These underwater volcanoes are the unsung heroes of our planet. They build the seafloor, drive the movement of continents, cycle essential chemicals, create unique habitats, and remind us of the incredible, restless energy contained within the Earth. They are a testament to the power and dynamism of our planet, mostly unseen but fundamentally shaping everything from the ground beneath our feet to the composition of the air we breathe. It's a humbling reminder that we've explored more of the surface of Mars than our own ocean depths, and who knows what other incredible volcanic secrets still lie hidden in the eternal darkness, waiting to be discovered. Thanks for exploring the fiery heart of our oceans with me today. Stay curious, stay healthy, and keep looking beneath the surface.